perimeter and area of similar figures. If I draw you two similar figures, there's two triangles. Those two triangles are similar. Right now you know that the base of one triangle is 3 and the base of the other triangle is 6. So something you have to be able to do is to set up a similarity proportion. Remember how to do that? Like set up a proportion. So if I did like base over base, the proportion would be 6 over 3. And that is like your scale factor. So how do you get from 3 to 6? Multiply by 2. So your scale factor is 6 over 3, aka 2. We were doing base over base. So if you had a number right here, 4, how long would this side be? 8. If you had a number right here, 5, this number would be 10. And that's all based on that similarity proportion or that scale factor. Multiply everything by 2. So today, we're going to add one extra layer. And I'm going to say that the area of this triangle equals 10. And you're going to want to say that the area of the big triangle is 20, right? And that's not necessarily the case. So when we do this, the scale factor from here to here, it's just number over number. But when we do the area, it's how do you want it? I don't want to. It'd be like the scale factor of the small triangle over the side length of the big triangle is equal to the area of the small triangle over the area of the big triangle. But now we have to do this because area is in square units. So when we compare area to area, you have to do it squared. So that's what the next page kind of says to you. When you have a scale factor, it's always like base over base. So the ratio of the perimeters would be A over B, your same scale factor. But the ratio of areas would be A squared over B squared. So I'm going to work through one problem to kind of show you how that works. So we'll just do a nice, easy rectangle. 2 and 6. And we'll make this a 4 and a 12. Alright, so you can use any number you want to identify a scale factor. And it doesn't really matter which way you go as long as you keep it consistent. So you can do small shape over big shape or big shape over small shape. How are you feeling today? Small over big or big over small? Small over big. So take a length from the small shape, 2, and its corresponding length of the big shape, 6. So this is your scale factor, A over B. Does that make sense? So the perimeters would follow the same scale factor. So if this length is 2, this length is, if this length is 4, okay, same smell over here. So the perimeter of the small shape is 4 plus 4 plus 2 plus 2, or 12. The perimeter of the big shape is 36. And those two proportions are equivalent to each other. Does that kind of make sense? So if you cross multiply 2 times 36 is 72, and 12 times 6 is 72. It makes equivalent proportions. Now, how you're going to see that today is it'll say perimeter equals 12, find the perimeter of that shape. So you do small shape over big shape equals the perimeter of the small shape over the perimeter of the big shape. And you cross multiply and solve for x. Now, today they won't give you all this information where you can just add it up around. That kind of makes sense? So if you cross multiply 2 times x is 2x, 12 times 6 is 72. Divide both sides by 2, and you get 36. And that is the perimeter when you add them all together. So it's kind of taking a shortcut step. And then the same thing goes here. What is the area of this shape? 2 times 4. 8 is the area. What is the area of this shape? So in this scenario, we have to use our scale factor. But we have to square these because area is always in square units. Because area is always in square units. So once I square these numbers, when you cross multiply them, oops, 72. When you cross multiply those numbers, it will be equivalent. And I'll do that real quick. 8 times 36. Eight times 36 is 288. And 4 times 72, 288. So the main process here is that perimeter is just A over B, the ratio, and area is A squared over B squared, the ratio. So those are the two things that we're going to set up today. So it says the figures in each pair are similar. Compare the first figure to the second figure and give the ratio of the perimeters, give the ratio of the areas. So we need to set up 3 ratios. What is our scale factor? What is our perimeter ratio? And what is our area ratio? So you have to pick big shape over small shape or small shape over big shape. Big over small. Okay, so what is our scale factor? The big shape compared to the small shape. 6 over 3. If you want to simplify that, you can. Does anybody want to simplify it? So instead of just saying 2, let's say that the scale factor is 2 over 1. Just to make it small numbers. So this is our scale factor. Try and leave it as a proportion so you know what you can cross multiply. So let's find the ratio of our perimeters. What is the ratio for perimeters? Yeah, it's the exact same thing. 2 over 1. A over B. And what is the ratio of our areas? It's A squared over B squared, or top squared over bottom squared. So our ratio of areas is, and if you want to simplify that to 4 over 1, that's what we're getting. So you kind of see some similarities. The scale factor and the perimeter ratio are always going to be the same, but the area ratio is going to be the top squared over the bottom squared. Alright, so just setting up practice, because you're going to have to be able to set these up to solve questions later. Does anybody have any issues with how we're doing this? Big shape over small shape, and then big shape squared over small shape squared for your area. Alright, try it again. It says we have 2 shapes here. set up a scale factor ratio, set up a perimeter ratio, and set up an area ratio. Big over small or small over big? Big over small. So our scale factor is going to be big over small, and that would translate to, so that is our scale factor, big over small. What is that also? That's also the ratio of perimeters. So our scale factor, 7 over 4, is the same as the ratio of our perimeters, 7 over 4. Now we need to find the ratio of our areas. And that's going to be the scale factor squared, because area is always units squared. So what is 7 squared? And what is 4 squared? So our area ratio is 49 over 16. Are y'all okay with this kind of math? I know it's kind of like, why are we doing this? And you're going to see here in a second. Okay, boom, here it is. The application of what we're learning today. It says these two figures are similar. The area of one figure is given. Find the area of the other figure to the nearest whole number. So, do you want to do big over small or small over big? Big over small. So our scale factor is 12 over 8. Now, it's asking for the area of the smaller pentagon. So, is this ratio going to work to solve for area? No, we have to have the ratio of areas. So we have to find our area ratio by squaring these numbers. 144 over 64 is our area ratio. Now, what shape does it give us? The big shape or the small shape? It gives us the small shape. See, it says the area of the small shape is 112. So we need to put the area of our small shape is 112. And we're solving for the area of our big shape. Otherwise, you have to do like 1/2 the apothem times the perimeter and a bunch of trigonometry and special right triangle tricks to figure that out. No thanks. So now you just cross multiply and solve for x. X times 64. 144 times 112. What?
16,000.
And then divide both sides by 64.
252.
So the area of the big shape is 252 meters squared. What do you think? Is there any easier way to do this? There's only one small way that you would consider more complicated, but might make your math easier. If you reduce this fraction earlier, instead of 12 over 8, if you make that 3 over 2, it would make this proportion be 9 over 4. Because 3 squared over 2 squared is 9. That would be a lot easier than 144 over 64. Does that make sense? That's the only way to make it easier, but it might make it more complicated for you by doing the extra math step. Does anybody like that step, making it 3 over 2? You don't like it? It's too much work. So you can leave big numbers there. It will always work. All right. Same smell here. We're trying to find the area of the smaller octagon. Area. So we need to set up a proportion. You want to do big over small or small over big? Big over small. So the ratio of lengths is 10 over 8. That's our scale factor. Because you don't want to do it, I'm going to do it. I'm going to reduce this down to 5 over 4. And your calculator will do that. So our real scale factor is 5 over 4. Just simplifying the fraction. You can type that in your calculator, 10 over 8, and it'll spit out 5 over 4. So if our scale factor is 5 over 4, we're trying to find an area. So what do we have to do to this scale factor? Square it. What is 5 squared over 4 squared? So this is big over small, and it says the area of the big octagon is 288. And we can use that to solve for the area of the small octagon. So if I do 288 times 16, you get 4,608. 25 times x is 25x. Divide both sides by 25, and it says to the nearest whole number, so it's just 184. So the area of the small octagon is 184 feet squared. It's always good to check, is the area of the small octagon smaller than the area of the big octagon? Yeah, so it kind of makes sense. Huh? If you used 100 over 80, yeah, it's the same number, you just get much bigger numbers here. Does it make sense? It's the same answer, but all these numbers are bigger. If you use the original scale factor, you get 100x and then like a giant number on the bottom. So you can use 5 squared over 4 squared or 10 squared over 8 squared. It doesn't really matter. Your calculator is smarter than all those numbers combined. So just kind of how much work you want to do. All right. This is like the most stereotypical math question out there. The longer side of a parallelogram are 6 feet. The longer sides of a similar parallelogram are 15 feet. The area of the small parallelogram is 27. What's the area of the large parallelogram? Holy math sentences. Okay, you have to pick big over small or small over big. Big over small. How long is the big parallelogram? The big one. No. How long is the big one? 15. How long is the small one? 6. This is your scale factor. We can do a little bit of math and reduce that. If you reduce that, you get it's just a nicer number to work with. Now, it says the area of the small parallelogram is 27. So we're trying to set up x over 27. That's big over small. Now I have to manipulate that proportion. I have to square it. So 5 squared is And 2 squared is, so this is the proportion I'm going to use to solve for the area of the bigger parallelogram. 25 times 27, 675. X times 4. Divide both sides by 4. Well, you know what? I don't want to do that. It doesn't say nearest whole number, so we'll leave it like that. 168. Please put your units there, feet squared, that way you know it's an area. Now, is the smaller, or is the bigger area bigger than the smaller area? We had 2 areas, 27 and 168. Does it work out? And are you freaking out like that's a really big number, isn't it? No? Just me? Anybody? You're just gonna move on with it? Okay. Yeah. Six times. Let's see. You can backward solve 27 divided by 6. This is 4.5. This will give you an area of 27. Yeah. So if you backward solve, you get 27. And what we get? 168. You can backward solve that one by doing the area divided by the length. 167 or 168. And you get 11.25. So you can see where the numbers come from. And if you set up these ratios like 6 over 15 and 4.5 over 11.25, you still get that same ratio. That's just a way to kind of use what we're doing to solve for more information. All right, the area of a nonagon is 34 meters squared. What is the area of a regular nonagon with sides 5 times the sides of the smaller nonagon? Ooh. What do you think here? You have 2 nonagons. The area of the small one's 34. The area of the bigger one, or the side lengths of the bigger one, are 5 times the length of the smaller one. So here's where you get to make your own proportion. You get to pick a side length for the small nonagon. One, that's a great decision. Okay, so if the side length of the small nonagon is 1, how long is the side length of the big nonagon? 5 times as big. So if you set up a proportion, what is the scale factor from the small nonagon to the big nonagon? 1 over 5. That's an easy proportion. So what would be the ratio of their areas? No. Square it. So this is small over big. What is the area of the small nonagon? 34. And we can use that to solve for the area of the big nonagon. 1 times x is x. 34 times 25. 850. So by choosing intelligent side links like 1, it made all the math easier. If you said, I don't know, 13, it would have made it a lot more complicated. So if it gives you an opportunity to pick your own side link, always choose 1. The area of this, so the side length of this nonagon is 1. The other one's 5 times bigger, so the side length over here is 5. Pretty smart, Baker. Oh, thanks. All right, the scale factor of 2 similar floors is 5 to 6. It costs $340 to tile the larger floor. At that rate, how much would it cost to tile the larger floor? What do you think? What's your scale factor? Huh? You do it squared? Is 340 an area? It's a cost. The wording's tricky, so let's see here. It costs $340 to tile the larger floor. Well, let's just do math and then we'll go back and see if it works. What do you think it's going to be? 5 squared over 6 squared, or just 5 over 6? Okay, so if we're thinking it's just 5 over 6, it says it costs $340 to tile the larger floor. So does that go on the top or the bottom? On the bottom. So 6 times x is 6x. And then 5 times 340. Divide both sides by 6. So $283 to tile the small floor. Let's see. So let's see, if you have a floor that's 5 by 5, it's 25 square feet. And if you have a floor that's 6 by 6, it's 36 square feet. So if you do, what's 340 divided by 36? 9? 9? So this is $9 per square foot. And then we said 283 was the other one, right? So what's 25 divided by 280, or 283 divided by 25? $283 divided by 25. Huh? So, did we do it right? Should it cost less money to tile the same floor or a bigger floor? It didn't work, did it? So what should we have done originally? So we, in this proportion, because we're comparing the area, the price to tile the area, we have to square these numbers. So that would be let's see, 25 times 340, 8,500 equals 25x divided by 25. Right? $236. So let's try that. 236 divided by 25 is $9.44 per square foot, and 340 divided by 36, $9.44 per square foot. So we're comparing the cost to cover an area, we have to square our formula. Alright, in the last section here it says the scale factor of two similar polygons is given. Find the ratio of their perimeters and find the ratio of their areas. So this is our scale factor. What is the ratio of their perimeters? Still 5 to 1. What is the ratio of their areas? Square both of them. 5 squared is 25, 1 squared is 1. Alright. This is our scale factor. What is their ratio of perimeters? What is their ratio of areas? Over 49, because 2 squared is 4 and 7 squared is 49. Alright, this is our scale factor. What is their ratio of perimeters? Oh. And what is their ratio of areas? 9 over 16. Alright, same thing here. I think you guys got that pretty good. We'll kind of leave it there. So I gave you guys an assignment. It kind of follows along what we did in class today. We're picking up both of these tomorrow. So hopefully you guys took those notes down at the beginning of class to kind of speed your process up. Then you have what you have today. The more you calculate on your calculator, the quicker this is going to be.